Welcome to the Continuum Lab. In this short video we will continue our look at these three instruments which I made for my recent workshop at the Barcelona Makerfaire. These instruments are prototypes meant for my prototype workshop, and as such these videos are not polished tutorials. Now I am preparing a final series of instrument designs which will form the core of future workshops, but this is where it all starts. So that's what this video is about. I filmed the making of all three instruments before the workshop, and this is the video about the wind instrument. I call it the boxophone because it is based on the fingerings of a saxophone, but it's made in the shape of a box. So to be honest, a box shape is not the most practical or playable shape that you can give to a wind instrument like this. But I was in a hurry to get this done in time for the Makerfaire workshop, and this box is what I had lying around. The breath sensor is the same type that I made for the original melodica. There will be a future video which explains the different kinds of DIY breath sensors in detail. For this project, however, and for the Makerfaire workshop, it comes pre-assembled. To prepare the box, I first figure out where I want to position my keys. I have no fixed measurements for this. Instead, I simply use my hands as a reference to make sure the instrument fits me comfortably. Next, I installed the pressure chamber for the breath sensor, perforating the box where needed, as well as cutting out sections to accommodate the entry and exit tubes. After that, I make the holes for the cables for each key. And then I insert the individual cables and glue them into place. The order of the cables starts from cable 0 on the multiplexer at the uppermost key in the left hand and goes down the keys as the sensor number goes up. After finishing the keys, there are still 3 cables left. These are drawn out to the octave key position as well as the pitch bend sensors. Now onto the sensor modules for the breath sensor. We will need an LED module as well as the BPW34 module for this. Insert each module under the rubber band of the pressure chamber facing each other and then plug them into the breakout board. The BPW34 goes in analog sensor slot 14, the LED simply goes to 3 volts and ground. Okay, so we still need to actually make the key sensors. I could have used the same copper sticky tape here that I used for many other instruments, but I decided to use conductive paint. One of the cool things about this solution is that no soldering is needed. I just put a drop of paint on top of each exposed cable end and then spread it out a bit, finger painting style. Yeah, I realize that the result is almost as ugly as is physically possible, but it still works, and that's kind of my whole point. Functionality and aesthetics are two completely different things, and one does not depend on the other at all. It would also work if it were beautifully done by a professional painter, so if you want to make one of these instruments, feel free to go all in on the aesthetics. As for myself, I just don't care very much about that, as should be obvious by now. The capacitive sensors need to be covered by a dielectric layer. I use normal transparent packing tape and it works great. Make sure you let the paint dry before applying the tape. The underside of the instrument gets the same treatment, although the double sensor that you can see here for the pitch bend interface was later moved to near the mouthpiece. Anyway, the concept for these sensors is always the same. Next, we install the calibration button. This is what allows each instrument to have differences in construction, like the exact size of the key sensors or the size and build of the breath sensor, and still function properly. While the button is pressed, the calibration routine will adjust the maximum and minimum readings on each sensor, which will correct the mapping of the values to compensate for differences in the sensors. I actually installed 2 buttons here, but I never ended up using the second one, so we can safely ignore that. The final touch is, of course, the USB cable. Cut a hole in the box like this, insert the cable and plug it into the Teensy LC. Make sure to organize the rat's nest of cables inside a bit so that no cables interfere with the sensor setup on the breath sensor. Okay, we're done. I hope you can appreciate how relatively easy it was to put this together, and this weird little wind instrument boxophone thing actually works. The breakout board, the sensor modules, and the built-in calibration routine mean that you get easy repeatability and consistency in the response of these instruments, even if you get a little bit creative in their construction. So take care until next time, and I'll see you in the continuum.